Some electronic devices, such as fireplace ignitors, can generate high-frequency electrical noise that can trigger arc fault circuit interrupter or AFCI breakers. This is a known issue with certain types of fireplaces and AFCI breakers. To resolve this, you can try the following. Firstly, replace the AFCI breaker with a standard circuit breaker, meaning non-AFCI. Secondly, use a different type of fireplace igniter that's compatible with AFCI breakers. Thirdly, install a suppressor device on the fireplace circuit to filter out the electrical noise. The 2020 National Electrical Code, or NEC, requires all 120 volts, 15 amps and 20 amps outlets in bedrooms to be protected by AFCI. Outlets that are not readily accessible, such as those behind fixed appliances, are exempt from the AFCI requirement. It is debatable whether a fireplace outlet is considered readily accessible. Some inspectors may interpret it as being accessible because it is used for operating the fireplace, while others may consider it inaccessible because it is typically not used frequently and requires tools to remove the faceplate. For the AFCI tripping issue, consult with the fireplace manufacturer or an electrician specializing in AFCI circuits to find a compatible solution. For the AFCI outlet requirement, discuss the issue with the inspector and provide your reasoning for interpreting the outlet as accessible. You may also consider installing a standard outlet for the fireplace and label it, quote, "not required for AFCI protection," end quote, to avoid any confusion. Let's delve deeper into the reasons why a fireplace igniter might trip an AFCI breaker and explore potential solutions in more detail. AFCI breakers are designed to detect specific electrical arc patterns that are indicative of dangerous conditions, such as those that could lead to a fire. These breakers are very sensitive and can sometimes be triggered by electrical noise or transient events that are not actually hazardous. Fireplace ignitors, especially those in newer models, often use electronic components to generate the spark needed to ignite the gas. These components can produce high-frequency electrical noise that the AFCI breaker misinterprets as an arc fault. Replacing the AFCI breaker with a standard breaker will certainly prevent the nuisance tripping. However, it also removes the arc fault protection that is intended to protect against potentially dangerous arc faults. This should only be considered as a last resort if other solutions are not feasible and if it is permissible by local electrical codes. Using a different type of fireplace igniter can be a more effective solution if the original igniter is known to cause problems with AFCI breakers. Some ignitors are designed with better filtering or shielding to reduce the amount of electrical noise they generate. Consult with the fireplace manufacturer or a qualified technician to identify an igniter that is compatible with AFCI breakers. Installing a suppressor device on the fireplace circuit is another viable option. A suppressor, such as a line filter or sedge suppressor, can help to attenuate the high-frequency electrical noise generated by the igniter, preventing it from triggering the AFCI breaker. These devices are relatively easy to install and can be a cost-effective solution. Now let's turn our attention to the AFCI outlet requirement and the debate over whether a fireplace outlet is considered readily accessible. The NEC defines readily accessible as, quote, capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, chairs, etc., end quote. The key phrase here is without requiring those to whom ready access is requisite to climb over or remove obstacles. In the case of a fireplace outlet, the question is whether the faceplate, or the location of the outlet behind the fireplace, constitutes an obstacle that prevents ready access. If the outlet is easily accessible and can be used without any special tools or effort, then it is more likely to be considered readily accessible and subject to the AFCI requirement. However, if the outlet is located behind a fixed appliance, such as the fireplace itself, or if it requires tools to remove the faceplate, then it could be argued that it is not readily accessible and is therefore exempt from the AFCI requirement. The interpretation of this requirement can vary depending on the local electrical inspector and their understanding of the specific circumstances. Therefore, it is important to have a clear and open discussion with the inspector to explain your reasoning and to come to a mutually agreeable solution. Installing a standard outlet for the fireplace and labeling it, quote, not required for AFCI protection, end quote, is a proactive approach that can help to avoid any confusion or misunderstandings. This clearly indicates that the outlet is intentionally not protected by an AFCI breaker and that it is not intended for general use. This approach may be acceptable to the inspector and can help to ensure compliance with the NEC while addressing the specific needs of the fireplace installation. In addition to these recommendations, it is also important to ensure that the wiring for the fireplace circuit is properly installed and grounded. A loose connection or faulty ground can create electrical noise that can contribute to AFCI breaker tripping. Inspect the wiring and connections to ensure that they are secure and in good condition. Consider using shielded wiring for the fireplace circuit to further reduce the amount of electrical noise that can be radiated into the surrounding area. Shielded wiring has a metallic shield that helps to block electromagnetic interference, or ME, and radio frequency interference, or RFI, which can contribute to AFCI breaker tripping. When consulting with an electrician, be sure to choose one who is experienced with AFCI circuits and who understands the nuances of the NEC requirements. An experienced electrician can help you to troubleshoot the problem, identify the source of the electrical noise, and recommend the most appropriate solution. They can also help you to navigate the local electrical codes and to ensure that your installation is compliant with all applicable regulations. Remember, electrical work can be dangerous, and it is always best to consult with a qualified professional if you are not comfortable performing the work yourself. Working with electricity requires knowledge, skill, and adherence to safety precautions to prevent injury or property damage. Consider the following additional points when dealing with AFCI breakers and fireplace ignitors. Firstly, AFCI breakers are designed to protect against arc faults, which are a leading cause of electrical fires. While nuisance tripping can be frustrating, it is important to remember that the breaker is doing its job by detecting potential hazards. Secondly, not all AFCI breakers are created equal. Some AFCI breakers are more sensitive to electrical noise than others. If you are experiencing nuisance tripping with a particular brand or model of AFCI breaker, you may want to try a different brand or model. Thirdly, the location of the AFCI breaker in the electrical panel can also affect its sensitivity to electrical noise. If the breaker is located near other sources of electrical noise, such as electronic devices or appliances, it may be more likely to trip. Try moving the breaker to a different location in the panel to see if that resolves the issue. Fourthly, the type of wiring used in the circuit can also affect the AFCI breaker's sensitivity to electrical noise. Older wiring may be more susceptible to electrical noise than newer wiring. Consider upgrading the wiring in the circuit if you are experiencing persistent nuisance tripping. Fifthly, the grounding system in your home can also affect the AFCI breaker's performance. A properly grounded electrical system can help to reduce electrical noise and prevent nuisance tripping. Ensure that your home's grounding system is properly installed and maintained. Sixthly, electrical noise can also be generated by other devices on the same circuit as the fireplace. Try disconnecting other devices from the circuit to see if that resolves the issue. If it does, then you know that one of those devices is the source of the electrical noise. Seventhly, electrical noise can also be generated by devices on other circuits in your home. Try turning off other circuits in your home to see if that resolves the issue. If it does, then you know that one of those circuits is the source of the electrical noise. Eighthly, electrical noise can also be generated by external sources, such as power lines or radio transmitters. In rare cases, external electrical noise can interfere with the operation of AFCI breakers. If you suspect that external electrical noise is the cause of the problem, you may want to consult with an electrical engineer to investigate the issue. Ninthly, AFCI breakers are designed to trip when they detect an arc fault. However, they can also trip due to other electrical problems such as overloads or short circuits. Ensure that the fireplace circuit is not overloaded and that there are no short circuits in the wiring. Tenthly, AFCI breakers have a limited lifespan and may need to be replaced periodically. If your AFCI breaker is old or malfunctioning, it may be more likely to trip. Consider replacing the breaker if it is old or if you suspect that it is malfunctioning. Remember to consult with a qualified electrician before performing any electrical work. The electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or property damage. Here are some additional tips for troubleshooting AFCI breaker tripping issues. Firstly, use a process of elimination to identify the source of the problem. Start by disconnecting all devices from the circuit and then gradually add them back one at a time until the breaker trips. This will help you to isolate the device that is causing the problem. Secondly, use a multimeter to check the voltage and current in the circuit. This can help you to identify any overloads or short circuits that may be causing the breaker to trip. Thirdly, use an oscilloscope to examine the waveform of the voltage and current in the circuit. This can help you to identify any electrical noise or transient events that may be triggering the breaker. Fourthly, consult with the AFCI breaker manufacturer for technical support. The manufacturer may have specific recommendations for troubleshooting AFCI breaker tripping issues. Fifthly, document your troubleshooting steps and results. This will help you to keep track of what you have tried and what has worked or not worked. It will also be helpful if you need to consult with an electrician or the AFCI breaker manufacturer. Sixthly, be patient and persistent. Troubleshooting electrical problems can be time-consuming and challenging. Do not give up easily. Keep trying different solutions until you find one that works. Seventhly, be safe. Always turn off the power to the circuit before working on it. Wear appropriate personal protective equipment, such as safety glasses and gloves. Do not work on electrical systems if you are not qualified to do so. Eighthly, consider the age of the electrical system. Older electrical systems may have wiring that is more prone to causing AFCI breakers to trip. If the electrical system is old, it may be time to upgrade it. Ninthly, think about environmental factors. Environmental factors, such as humidity and temperature, can affect the performance of electrical systems. If the humidity is high or the temperature is extreme, it may be more likely that AFCI breakers will trip. 10thly, when in doubt, call a qualified electrician. If you are not comfortable troubleshooting electrical problems yourself, or if you have tried everything and nothing has worked, it is time to call a qualified electrician. An electrician has the knowledge, skills, and experience to diagnose and repair electrical problems safely and effectively.